Let's do one more question which appears to be interesting. So let's say red color. We have an equation y question. Y is equal to 2x cube minus 6x square. Yeah?
Yep.
So first of all, the first part, find y-intercept. How to find that?
Uh, you have to find, you have to make it so that x is equal to 0.
Yeah. So what would be the y-intercept? Y at x is equal to 0.
0.
0. So it means the y-intercept is actually 0.00. So it is going through the origin.
Yep.
Okay, good. And then you have to find now the b part, x-intercepts. How to find the x-intercept?
You have to make y 0.
Yeah, y 0. So it would become 0 is equal to 2x cube minus 6x square. Can you help me to find the x-intercept now? Naturally, it appears that there are more than one points which are there. Can you solve this question and let me know what or help me, guide me how to find the x-intercept?
Uh, you factorize
Yeah,
it.
we factorize. So what should I do?
2x.
2x, or can I take 2x square?
You,
Because
I think yeah, 2x squared.
so 2x square. So it becomes x
X
minus
minus
3
3. Yep.
is equal to 0. Yeah. Now this is a null factor form. Do you know the null factor form? Null factor form. This is now in a null factor form. What is meant by null factor form? If
I
a
heard
into
of it.
b is equal to 0, it means either e- either a is equal to 0 or b is equal to 0 or
Yep.
both. So it means you would say 2x square is equal to 0 or x minus 3 is equal to 0. Yeah. So what is meant by this? If this means the point is, if I take this one where I am writing it, so x is equal to,
X is equal to uh 3.
oh, here you are saying this is x
Yep.
is equal to 3. What about the other?
0.
Yeah, 0. So it means it has 2 points where it is, the graph is cutting the x-axis. It is at 0, 0 and, so it
And
means it is at 0, 0 and 3, 0.
yep.
It is getting the x-intercept. X-intercepts. Do you understand that? Yes?
Yep.
Okay. Now we move to the third part. Um, we have to find the behavior. So let me take third part. How is y as x tends to infinity, positive infinity, x tends to positive infinity, and x tends to negative infinity. Do you understand this or no?
Not really.
If you put like this, the graph, the question which we did earlier, which had something which the shape was like this. Do you remember the previous question, or should I go there? I would just go there
Uh,
instead of,
okay.
because that's a benefit of having it. So if you see here, x tends to infinity means we move x. So what is happening to y? It is going up. So it means if x is going to infinity, positive, y is also going to positive infinity. Do you see this?
Yep.
What about on the other side? If x goes to negative infinity means it is moving towards, I put my mouse in this direction. So what is happening to the y? Y is moving towards,
Y is moving towards positive infinity.
very nice, very nice. So it is moving towards positive. So, so we would check on the basis of this, our we would check our question like this, right?
Yep.
Are you good? So we had the equation which was actually uh, the equation which we had was actually, let me write on here. We had y is equal to, what was the equation? The y was 2x cubed minus 6x square, right? And we
Yep.
say if the x goes towards positive infinity, which term would dominate, x cube or x square?
X cube.
Yeah,
X cube.
yeah, dominate because it would be giving a bigger point, right? So
Yep.
if x is going towards infinity, it means I would just take this term is dominating x cube. There is a minus term with x square, but this would more dominate. Therefore, y would be going towards positive infinity. Do you understand this, or should I repeat?
I understand this.
What about once the x is going towards negative infinity?
Uh, when x is going towards negative infinity, y is going towards negative infinity.
Yeah, because here this would be square, so it would be negative, and here x cube is negative, so negative, negative. So this is clear, right?
Yep.
So this is something which we found out here. Okay. So we know now where is the x-intercept, we know where are the y-intercept, and we know how it's behaving in the now third part, stationary point and the functions. Stationary point, and then we would stationary points. Find stationary points. We would find the stationary point and then draw it. So we had the y is equal to 2x cubed minus 6. Can you help me to find that the stationary point? How to find that?
We first find the dy by dx.
So what is dy upon dx? Because the equation is just in front of you here. 2x cubed minus 6x
6x squared minus 12x
minus 12x. And we should put it equal to what? Because
equals to 0.
yeah. Can you help me to solve this? So we take what
Uh,
common? We factorize that.
we factorize and take 6x.
So 6x x minus 2 is equal to 0. So what are those points now? X is equal to
X is equal to 0
and
and 2.
yeah, that's very nice. That's very nice. So we have now two stationary points, but we do not know whether these stationary points are minima or the maximum. So we would first check x is equal to 0.
Yep.
So what we would do, we would put dy upon dx and put 2 points, one on the right side and one on the left side. What point you would like to that we should check? Dy upon dx at x is equal to, because we know it is at 0. So we would take 1 point just above 0 and 1 point lower than 0.
0.5 and 1.2.
0.5 is a little far away. I would be, we just take 0.1.
Okay.
So what would be 0.1? Dy upon dx at 0.1? 6 times, because we know what is 6
Yep.
times 0.1 square minus 12 times 0.1.
1.
Is it good?
Yep.
Okay. So what is the answer then?
Uh, 0.06 minus 0
No,
minus 1
minus
1.2.
1.2.
Yep.
So what is the answer?
Uh, can I use my calculator
Yeah,
for
yeah, yeah.
this?
Certainly use the calculator. I was thinking that you are using the calculator.
Okay.
Sorry.
Negative 1.14.
So it's a negative. We are just concerned about the sign. So it means it's negative, right?
Yep.
And what about if we put dy upon dx? Let's take even x is equal to minus zero point 0.1. And we have to see what is the sign.
6 in brackets minus 0.1 minus 12 in brackets negative 0.1 0.6
So sign, is it positive or negative?
positive.
So we are more concerned. We are no, we are not very concerned about the. So this is something interesting. What we found that x is, there was a y-intercept. So I would try to make this. So we found that, let me do this on the red color. So just I rub that, and we found that at 0 it is a point of inflection. There is a, there at minus it is negative, and at, yeah, at zero point 0.1 it was, at zero point 0.1, which was here, yeah, it was
Yeah.
positive.
Mm-hmm.
And so at 0 it was a positive, and at, no, at zero point 0.1 it is negative, so it means it is going down like this, right?
Yep.
And before it is positive, so it means it is negative, and here positive, so it is something like this. Do you see this?
Yep.
And we know at infinity, which you have already said, as it is going, so it means y is going towards infinity.
Okay.
Do you see this?
Yep.
Like this, I just rub this a little bit, because we found earlier that x, as x was going towards infinity, y is going towards minus infinity, right? So this is something which we found, right? And then we had a second minima at, one was at 0, 0, you found two stationary points, and the second was 2, yeah?
Yep.
So 2, 1 and 2. And we have to see what is the point of y. So we wouldn't like to point the inflection, because that we know the where the point, stationary point. So this we found out was 0, 0. Because why? Because we knew once we put 0, so it was y also becomes 0. We had the equation y is equal to 2x cubed minus 6x square. So putting x is equal to 0, y was 0. Now we want to write y is equal to 2. What is at x is equal to 2? What is the y? 2
When
times 2 raised to the power cube minus 6 times 2 raised to the power 2. Can you solve and let me know the answer?
okay, 2 to the power of 3.
16 minus 20. 16 minus 24.
Negative 8.
Yeah, negative. So it means that the second inflection point is actually 2 comma negative 8, right?
Yep.
Oh, stationary point, I say, not the inflection. So 2 comma minus 8. So it would be
Yep.
somewhere here. Are you good with this or no?
Yep.
And I put this thing like a minus 8. And this is minus 8. And this is 2. So this is 2 comma minus 8. Yes? Now we have to see, is it a minima or a maxima? We had, because we checked it for 0, 0, that was the maxima. Now we would check it for this point, right? So what we want, dy upon dx at what point you would check? Because we know x is equal to 2. Maybe at x is equal to 2.1?
Yep.
Okay. I leave it to you as an assignment. At
Okay.
2.1 it would be positive, and at 2.1.9 maybe, at dy
Mhm.
upon dx at x is equal to 1.9, it would be negative. So it means
Negative.
it means we will have something like here and here. So it means it is positive and it is negative. So it would be something like this. Do you see this?
Yep.
And we had already found that the y-intercept were the x-intercept. There were two x-intercepts we have found earlier. Let me go there. Um, we had found the x-intercept in the here. We had that 0, 0 and 3, 0. So x-intercept was here. So it means it is going here. This is 0.30. Yeah. And we have found also that as x was going to infinity here, the y was also going to positive infinity. So we would say this is going like this. So this is the graph. Do you see that how we made it?
Yep.
Okay. So we are clear about it, right? So um, I think we would be finishing the lecture.